Hi, it's Joe Menchevsky, the host of Better Buildings for Humans. This is a series of conversations with thought leaders about indoor environmental quality. We're going to talk about daylight, views, fresh air, and thermal comfort, and so much more. These conversations are for architects, designers, engineers, building owners, people who care about the comfort, health, and productivity of the people who work, live, and play in their buildings. Come join us if you want to be a part of the conversation. I was really excited about the opportunity to speak with today's guests. Stefano Schiavon of UC Berkeley studies all of the factors for human comfort while simultaneously looking for ways to reduce energy consumption. His body of work aligns perfectly with the reason Better Buildings for Humans was created in the first place. You're going to love listening to Stefano. He's insightful, occasionally mind-blowing, and most importantly, he is very optimistic about our ability to create better buildings. And by the way, if this content is valuable to you, if you're enjoying it, please hit like and subscribe. Thank you. Stefano, welcome. It is an absolute honor to have this opportunity to have a conversation with you. Let's start this whole thing by you telling us where you work and a little bit about your research.
Hi, Joe. Nice to be here. I'm Stefano Schiavon. I'm a professor of architecture and civil environmental engineering at the University of California, Berkeley. I have a background in mechanical and energy engineering, and in times I start to look at how can we reduce the impact that building has on the environment, mainly looking at the energy that they use for heating, for cooling, for ventilation. And I also look at the impact that the indoor environment has on people. So how the temperature, the lighting, the acoustics, the air quality affect our health, our well-being, our ability to learn, our ability to work.
Well, that is wonderful, because those are the kinds of things I want to talk about. And you've done some really diverse things, so we're gonna try to cover a lot of stuff today. So I'm really excited, and I think the people that watch this channel will be really excited too. So let's start by talking about your research on common sources of occupant dissatisfaction. I really like that one. So temperature was the number two most important factor. Is that as simple as, everybody wants to be in control of the thermostat, or is there something more to it than that?
I think that you touched the most important point, that differently with other conditions, for example, lighting, where it's relatively doable to have some kind of control of it. You can buy a desk light that can change the color and the intensity. We don't have similar solution, or at least easy to use solution for temperature. And so we've been going around now for decades asking people what they like and they don't like in buildings. And something that came out systematically throughout the years is that people are unhappy with the thermal environment. We only have roughly 40% of the people that are happy and 40% that are unhappy, and 20% that do not have a strong opinion.
Yeah.
And we know that the most effective strategies to increase their comfort is to provide some kind of control. If you are in a private office, it's easy. You have control if that office is controlled with a thermostat that is able to, react to the condition and your request. But then if you're in an open space, or if you need to share your space with multiple people, then we have the problem that usually the temperature or the thermal condition is the same for most people there.
Right. Are there any sort of strategies or technologies for that sort of scenario?
Yes, and some of them, many people are already using. When you go around buildings and office environment, you often see a heater under the desk, and that is a way to personalize that. And so we support this type of solution, but we are looking for energy efficient option, because a typical heater is 1500 watts. That's too much.
Yeah.
We are looking for a way to provide the same effect, but using much less energy. And so, for example, in winter, a good solution are electric blanket or heated mat. You can put your feet on a heated mat that you put on the floor. Maybe it's 50, 100 watts, and it gives you a strong sensation of well-being. Or if you are, for example, in a residential building and you watch TV or you go to bed, an electric blanket tend to be more efficient than warming up the entire house.
Really interesting. Do you think that will be an easy adoption in an office environment?
In an office environment, there is two main solutions that we have seen people using.
Yeah.
They heat it under the desk, and we want to avoid that given that it's so energy consuming. So we prefer all radiant panel, or even better, anything that is contact based, because when the heat is in contact with your body, it's order of magnitude more efficient. And so that's why a floor mat works better than a heater. Or we have done a lot of research on heated chair. They work very well, but still we didn't see them a deep penetration in the market.
That's really, really interesting. Okay, I have to ask you about the methodology that you used to do some of this research, specifically your wearable technologies. Tell us a little bit about the wearable technology you used in order to study the occupant satisfaction and dissatisfaction.
Yeah. So we make buildings for people. And so taking into account what they like and what they don't like is very important. And many of the solutions that we use, for example, in the heating domain or cooling domain, it's a thermostat. But the temperature is not a good proxy of how people are feeling. A much better way is to ask people, do they like, do they don't like, do they want warmer, do they want cooler? And of course, that is the best option out there, but it's also bothering people. Maybe people do not want to invest the time for that. And so trying to get closer to people, for example, measuring their skin temperature or their heart rate may help us to create a better thermal environment. I didn't do research, for example, on lighting, but some people are looking at, for example, at your pupil size and maybe regulating the lighting level on that. The problem is that the technology for doing that is still far away from being available on the market. But we have, for the wearable aspect, we have already solutions that are relatively affordable, somehow used already in the marketplace. And therefore, we could learn something from the information that people has and provide with this wearable and use them to control. And if you're in an office environment, maybe you do not need automation for heating and cooling. If you have a fan, you can directly control yourself. If you have a heating element, you can control it. But for example, when you are sleeping, that becomes very important because there you are not able to regulate the temperature. And therefore, we want to avoid people waking up in the middle of the night that they are too hot or too cold, sweating. And so in that condition, having a physiological parameter controlling the environment may be valuable.
That is wonderful. That is really, really interesting. And really, gosh, I hadn't realized that we've gotten that far. And I hope we keep moving in that direction. Along the same line, you did some really interesting and maybe even controversial research on the relationship between indoor temperature and work performance. And you found that there was no correlation between temperature and work performance. I know, the industry has kind of had that magic 22 degrees Celsius number for many, many years. And you've debunked that belief. Can you tell us a little bit about what that means and why that's important?
Yeah, first of all, it's a complex topic. And so it requires thinking and nuances, and it's hard to simplify. But there are some important aspects. The first one is that measuring work performance has been proven challenging, at least for the type of experiment that we tend to do. And so we tend to simplify the issue of work performance by looking at some of the dimension, how fast you type, how many calculations you can do, how well you remember a certain sequence of number. But we all realize that our work performance is a complex metrics that is even company, have some challenges to measure them in a reliable way or in a way that reflect the outcome that the company are interested into. But my aim on the work of debunking that relationship between temperature and work performance comes from two ideas. First of all, when I look at the data, I say, this is an artifact of the model that they used, meaning that if they had another assumption in their head, they would have been able to obtain an equally predictive model. And so in the approach that they use, they assume that the relationship between performance and temperature was following a parabolic, a quadratic curve with one peak point and then a collapse. And there is another theory happening around that say, maybe you're okay within a certain range and then your performance tend to degrade. This one is named the extended U shape. And there's been quite a lot of work in several other fields showing that could be a better representation. And we all know that if you're at 5 degrees C or if you're at 45 degrees C, your work performance has been reduced. I think no one doubts that.
Right.
Our discussion is what if or what is happening within the built environment when temperature usually rarely vary are below 18 or above 28. Is there an effect on performance? And our work, I think, put a solid stop to the idea that there is one temperature, or at least that you can have an equation that point out to a specific point. But we didn't disprove that the thermal environment may affect performance. I think that that's still possible. I don't think that that specific work or that specific 22 is the right value. And there are several reasons of why. First of all, they studied from different conditions, different people, different way to measure work performance, and then they put them together. And when they put them together, if you look at the data, it's basically a cloud. There is almost impossible to detect a pattern. In fact, when we recreate their database, we started to fit a model where the peak performance were 20 degrees, other model where there was a wide range of temperatures that were acceptable, and the result was always the same prediction accuracy. And the prediction accuracy was very low, 5%, meaning that the best possible model explained only 5% of the variation that you see in the data. The other 95% was not related to temperature, means that there was something else that was causing that variation in performance.
Okay.
And also when we use a model to say that there is no relationship, it has equal performance on the data. And so we first concluded that we cannot use the value of peak 22, and I don't think that anyone can dispute that. We also expanded our database, collecting more data, looking at newer studies, and the results were similar. We knew that the results were very controversial, and so we did a couple of steps that I think are important in science. We took the data and we made them public, so anyone else out there can look at the data that we collected and check out if our results are correct. And we also built a tool that people can use to explore our database to see if by looking at the data in a different way, they can find a particular trend. Since it has been published, I don't think that we found anyone pointing out to an error in that work. And so we are pretty confident. I guess that what is needed now is, should we build a better experiment? Should we try to run the same experiment in different parts of the world? Should we look at the thermal environment in a little bit more nuanced way than just temperature? Maybe it's the combination of airspeed, humidity, the type of activity, and many personal factors. Maybe there are people that when they are exposed to a stressor answer differently than others. We accept that in physical sciences or in sport sciences, where if I run for 100 meters, my performance are much worse than the performance of my son, that is a teenager, and probably are better than the performance of my father, that is older than me. And so it's possible that when we receive a stressor, we may react differently.
Are there other factors within indoor environmental quality that follow the same sort of I'll call it a non-pattern, or no correlation, or like, for example, natural light or views? We know that there are extremes, like a glare situation will definitely reduce productivity, but do you find an optimization in terms of daylight, for example?
I'm not a daylighting expert, but
Sure.
I expected that this phenomenon of not having one value, or at least one value that is valid for everybody, but having maybe a range, and a range that change on according to some parameter is reasonable. It's like, is there an ideal blood pressure, or is there an ideal heart rate? We know that
Right.
it changes. It may be that the blood pressure within a certain range is fine, and it may be that a certain luminance level may be okay for some people. It may be different for other people. It's just that by better studying the topic, by going deeper, by having a more accurate experiment, by being able to merge the data collected from different labs, we may be able to have a more personalized understanding of what we need. And I think that that's reasonable also for any environmental quality situation that goes from, air quality to lighting to acoustics to the thermal environment. It is possible that there will be a range where we work well and range where we do not work well, and that those range may not be universal.
That's really interesting. That was actually going to be my next question as to how personal that was going to be, and you've just answered it. What's your guess? Is it going to be not universal?
Yeah, I think it's we have many things in common as humans, and so I think that everybody will find a 35-degree C room uncomfortable to work.
Right.
But then what will be the best condition for each of us may be slightly different. So I don't think that the difference between people will be 15 degrees, but I think it's reasonable to expect that 5 to 8 could be possible. That I work best at 21, someone may work best at 26. And we need to find a way to personalize the environment.
Interesting. A factory floor scenario. Have you considered that scenario at all? And the complexities with being on a like the equivalent of an assembly line.
Yeah.
How complex does that make the situation?
I think that in a factory floor where error can lead to incident or to a problem with the product that you're having, it's important to create a comfortable and safe condition. And so there's been work showing that if we improve factory floors by keeping them cleaner, by organizing them better, by providing natural lighting, by providing biophilic element, that could be a positive outcome. And I think that we are going towards a future where work is always becoming more complex, it requires more content demand. Therefore, we need to provide a safe and comfortable environment in almost any place where people are working.
Wonderful. Okay, let's change the topic just a little bit. I want to talk about fresh air. I when I think of IEQ, I think of daylighting, views, temperatures, and of course, fresh air. I saw a study recently that talked about the negative impact on performance when CO2 levels are too high. Do you think current building codes are adequate in general in order to bring in sufficient quantities of fresh air to increase occupant satisfaction and productivity? Are the codes where they need to be?
even the issue of air quality is very complex, meaning that there is a wide range of pollutants in the air. And so
Right.
we ventilate for different objectives. Sometimes we ventilate to have the air perceived good by people. Other times we ventilate with the objective to keep specific pollutant below a certain value. And so because we don't want to have, for example, particles or VOC at a too high level in the space. And there are several techniques to achieve those type of goals. One of them is avoiding that you have bad sources in the environment. And so if you know that frying food in your house is a source of pollutant, you may decide to not do that or to fry that outside. Or if there is other source like combustion inside the building, you try to avoid. Or if you know that some material emit more than other, you avoid to bring that material.
Right.
That's one line of defense, controlling the source. The other line of defense is to dilute that pollutant by bringing clean air. That clean air could come from the outside, or could be air that somehow you clean it with filtration, for example, or in case of viruses with disinfection. And so you take that air and you bring it into the space. And the airflow rate that has been determined usually try to meet several goals at the same time. Sometimes they try to meet the goal of, not having too many people complaining that the air is smelly, but also trying to have some health objective in mind. And the premier standard in the United States is ASHE 62.1 that suggests ventilation rate that are proportional to the number of people and to how much material you have in your space. And so it's proportional to the floor area of the space. And they are slightly lower than, for example, the one that Europeans are suggesting. Right now, there's been a big debate on should we increase them for the reduction of spread of disease. And it seems that there is evidence showing that if you provide more air, you may have an advantage of that. And that has been one of the techniques that has been using during COVID. And now those techniques are becoming legislation or new standards with the idea that if you are in a period, for example, of high transmission of airborne disease like influenza, you may want to find ways to bring more outdoor air in or have other means to clean the air, like, for example, filtration and disinfection.
So if you bring in more air, does that have a negative impact on your energy consumption? Is that a trade-off?
In some situations, yes. For example, if your outside climate, I'm right now in Singapore, it's very hot and humid. If you bring more outdoor air, it will be expensive. If you are in winter in Minneapolis or in Oslo, bringing more air may lead to an increase in energy consumption. There are other situations where if you are lucky enough to live in Sydney or in California, you bring more outdoor air, you don't have a major energy implication in some times of the year. And so in that situation, there could be other consideration, like, for example, do we want to do some heat recovery? And so when you bring outside air, you pre-warm with the air that you exhaust. Or are you trying to have a more personalized environment? So you allow the building to fluctuate in a wider range of temperature, but at the same time, you provide comfort with a personalized solution. So I think that it's not a necessary negative outcome bringing more outdoor air. It pushes maybe the design community and the manufacturer to think about products that could reduce the environmental impact. But I think it's possible that in some situation there will be an increase in energy consumption.
Yeah, no, I like that. There's always trade-offs, but you've described ways for reducing those trade-offs. So that's great to hear. I have to talk a little bit about daylight views. It's a world that I'm involved in. I know you've done some research with Michael Kent, who I spoke to earlier in the year, studying view quality and glare. let's talk a little bit about the impact of windows on thermal comfort. Is there a trade-off between views and optimizing views and thermal comfort? Have you studied
Hmm.
that sort of balancing act?
First of all, I think that view is a very exciting topic.
Yes,
I,
yes, me
I
too.
I didn't start my research on it, and we have quite a lot of knowledge on daylighting and lighting and glare.
Yeah,
But the issue of what we see out of our windows has been somehow neglected. And we are far behind on that. And so I'm excited to see PhD students and researchers and companies that want to better understand. And it's a complex topic that imply, what we see outside, how clearly we see through the glass, how much access we have to these views. And so I think that in view, it's important for people well-being and health. And one dimension, probably a secondary one, is the one connected to the thermal environment. We have done some experiments showing that when you are close to a windows, you are more forgiving if the thermal conditions are slightly off. Overall, I think that the interaction between lighting and thermal are relatively minor. People are looking at them, and if you're in a room that is, with very warm colors and warm light, maybe you feel slightly warmer. But these are not the things that are the game changer. I think that we want a view for much more fundamental aspect, that is that desire to be connected to the outdoor, ideally to nature, the desire to be in a dynamic environment. You remember when we discussed earlier about the issue of the peak condition? I think that
yes,
that idea is problematic because that idea led us to think that, we could put people in a box, give the perfect light, the perfect temperature, the perfect noise, and people will be happy. It's like to say, I'm going to force you to eat pizza. I think pizza is great, but if you eat it every day, at a certain point you will get tired.
right.
Somehow, similarly, we need to create a dynamic indoor condition. And the outdoor environment is a perfect source of that condition. The cloud move, the wind moves the
Yes.
leaves. I can see animal, I can see people. Way more interesting than, a static, perfect, bright light.
Right, right. Yeah, the movement of the sun across the sky and the
Yes.
slight variations in the spectrum as you get closer to the horizon at the beginning and end of the day. Yeah, yeah, interesting. Have you ever looked at diffuse light as a way,
Hmm.
like, in combination with transparent glass, like a diffused light that's softer and less creates less thermal discomfort and less glare situation. Was that involved in your research at all?
No, I did not look at this aspect.
Yes,
I know how it's important to have light coming in different form. Uh, First of all, we know that we need large amount of light. It seems
right.
that when we are indoor, we are exposed to too little. And I'm a big proponent of having people close to the facade because this connection to the outside is important.
Yep.
And we know that when you are close to the facade, suddenly it becomes very complex, the problem. You have acoustics, you have lighting, you have glare, you have thermal condition, you have asymmetry. And so I want to invite our community to not try to keep conditions the same all the time. It seems that from multiple aspects, it's like, we have learned in time that stimulating our body is important. At a certain point throughout our evolution, when we didn't have to do manual work, we thought that stay sitting on the sofa all the time was great, and eating as much as possible and never be hungry was great. And then now we learn that too much of a good things can be bad. And so sometimes not eating too much or be hungry for a while or do physical exercise is a good stimulant. We now start to understand that if the same is true also for example, the thermal environment, exposing our body to some extreme, not extreme that damage us, but for example, swimming in a cold pool or doing a sauna may be good for our body to be exposed, I think that any type of variation may be valuable for our outcome. And so thinking about also how the lighting environment could sometime expose us to dark condition or bright conditions may be valuable.
Interesting. That's really, really cool. I'm going to change the subject entirely once again because I want to. There's so many things that we could talk about. I want to make sure I cover a few. The ASHRAE Global Thermal Comfort Database, Part Two, I guess it is. I understand you have some involvement with that. What's your role in that project?
So roughly some decades ago, ASHRAE put together a database of real measurement in comfort in building. And that was the basis of the adaptive comfort that Richard Deere and Gail Brecker in the United States and Australia led. Thanks to that work, people started to follow a standardized protocol to assess comfort in real buildings. And so in years after years, those data has been accumulated, and our aim, and so this is a combined efforts between, again, the University of Sydney, UC Berkeley, and many other researchers all around the world that help us, with many of them being volunteers, to try to say, okay, can we put this data together? Because in the moment that you have a larger database, you may have a deeper understanding. And we've seen this being a catalyst of research. I rarely notice that when you create a data set, how many research, because usually researchers have some idea of what they want to study. And then they collect the data and then they do an analysis and then it's ended there. But it's possible that the same data could help us to answer different questions. And I have a personal story connected to that. When I was a student, I looked at the original ASHRAE Global Thermal Comfort Database 1, and I wanted to build a model on relating how much clothing we wear based on outside temperature. And this is important because when we do energy modeling, we often simplify the world and assume that we have only a winter and a summer clothing. But we know that how we dress change almost, every week. And in shoulder season, we have something in the middle between summer and the winter. And so I was able to build that model thanks to the database. And so we wanted to do something similar now that we have a much larger database. And we have seen people now looking at the database and started to come up with a new idea on how comfort can be done. It will be great to start to do similar efforts in other fields, in lighting, in view. And so the efforts of each group can be multiplied by putting together the data, and so having a more reliable database.
Fantastic. Do you plan on using that database for any particular research in the near future?
We use already the database, for example, to prove that the most common thermal comfort model that is out there, the PMV PPD model, is not very accurate. In the PMV, we found that it's able to get the right answer 1 time out of 3. Meaning that 2 times out of 3 is not getting the right result. We use the same model to, for example, to build some machine learning-based, AI-based tool to, let's say, try to predict comfort by just using air temperature instead of a more comprehensive system. And we also show that the PPD, the prediction of the percentage of dissatisfied, is completely unreliable. And based on that database, we remove it from the standard, the ASHRAE standard 55, because we realized that it was not, it has a prediction accuracy close to 0.
That's quite substantial.
Yeah, we were able to change standards and the way that people design thanks to that model. And for example, in the case of the accuracy of the PMV, we don't have out there a better model right now that can substitute that. But at least it gives a guideline to designer to understand that maybe, it doesn't make sense to try to do an optimization and improving 0.01 of the PMV because it's not very accurate. And so allow them to understand that, some type of optimization may not be needed.
Fantastic. All right. One final question. Modern building codes putting a lot of emphasis on building envelope thermal performance.
Mhm.
And the most energy efficient building envelope is opaque, which disconnects the building occupants from the outside world. Do you worry, are you concerned that it might drive the design of buildings back to the 1970s when there was lots of opaque elements in the occasional punch out and again, further isolate us from our natural world that we crave so much? Is that a concern of yours?
I'm not particularly concerned about it because I see some major trend in the industry. The first one is that we now think much more about creating healthy environment. And in order to achieve that goal, we know that access to view, access to natural light is important. And plus many other dimensions, for example, the one of reducing the spread of infectious disease. And that is a major driver. Another important driver is that we are not only looking at energy, but we are looking at carbon. So both how much energy buildings are using, but also how much energy or embedded carbon there is in the building material. So we are starting to be much more nuanced in the discussion. Yeah. We also learn that there are several trade-offs between view or daylighting and the thermal, but there are also other dimensions that play an important role. For example, the issue of acoustics or the issue of biophilia. And so my idea is that the designers are becoming better. They have more tools to be more refined and be able to give more detailed or more nuanced solution. The fact also that we have much better tools for designing allowed for a more thoughtful result. And so overall, I've seen a progression in the industry on being able to embrace complexity and come up with solutions that are better than the one that we had in the past. And as you notice, I do not answer specifically to your question and say, is one solution better than the other? Because it's so contextual that if you design a building in Singapore, you may need a ratio of transparent to opaque for a residential building that is different from a commercial building that is different from something that you design in the Bay Area. Something that I would love to see in design codes, it's related to two other issues that to me are very dear. The first is that I would love to see a more homogenization, global homogenization of standards. If you design a phone, if you design a computer, if you design a telecommunication system, if you design food, if you design an airplane, the standard that you follow in China may be very similar to the one that you have in Germany and very similar to the one that you have in Canada. With the building sector is extremely fragmented. A building that can be built in San Francisco cannot be built in LA, and it cannot be built in New York, or it cannot be built in Berlin. And that is slowing down our industry. Of course, local conditions are important, but I think that there is a base that is the same that could become much more global. And I would love to see us going towards a more common ground that still allowed for some local flexibility and innovation, but some structure are the same. So this is an important aspect. The other important aspect, I think that the way that we interact with standards, it's very, very old, almost medieval. You find a PDF, you download it, you don't know if it's the most updated version, and then you search it. The more the world has moved on, we have now the ability to uh, have access. We should have the ability to have access to all the code at the same time. Have AI tools that help us to navigate them, and have a lot of automation that check if our design comply with the code. Uh, and that's a big issue right now that the designer, I talk with many of them, they are concerned every time that they submit a design document, they do not know if the authority having jurisdiction will approve or not. It's too arbitrary. We need to go towards a future where you may have a software that, at least in part, will be able to check do you comply or not. And there are things, egress, door size, uh, loading, how many toilets, how many faucets I need. That
Right.
should be, easy to automate. And so I hope that the codes will go in those two directions.
That is wonderful. That is wonderful. Stefano, I can't thank you enough. Wait until the architectural world sees this
Mm.
conversation. I think there's a lot to be learned. I think you're going to get a lot of people thinking and stimulated and excited about the future of design, especially with regards to the impact it's going to have on the occupants. I thank you, and I appreciate your time, and the architects of the world and designers of the world will appreciate your time as well. Thank you.
Joe, thank you very much.
This conversation was made possible by Advanced Glazings, helping you to make the connection to the outdoor environment through daylight and views. Solera and Solera Wow, highly insulating light diffusing glass, will help you to create buildings that are stunning and will wow everyone who enters.